Verkerk-Evers Group is the global leader in the design, construction and installation of technically advanced facades. In our 50-year history, we have created envelopes for some of the world's most iconic buildings. As sustainability leader for Scheldebouw, Verkerk-Evers Group's brand based in the Netherlands, one of my roles is to provide information about the environmental impact of the facades we manufacture. This can be challenging. Our products are all bespoke and the process for fabricating each design is unique, involving different materials, a long list of components and a range of suppliers. On the other hand, the customized nature of our designs provides us with a powerful opportunity to optimize the environmental performance of each specific facade. To compile a life cycle analysis for a unitized facade, we need to collect a lot of information from a wide range of sources. We need to analyze the design and know exactly which materials are in it, in what quantities. We need to know the processes needed to manufacture these components. We need to know the location of the different suppliers so we can work out transportation distances. Then we need to know the energy use and additional materials needed to assemble the facade elements like primer, cleaner and packaging. And to complete the picture at the construction stage, we need to add transportation to the building site and the energy use for installation activities. This is clearly a lot of information to collect, and we've not even begun to consider assumptions about the use of the building and what happens at the end of use stage. Traditionally, a consultant is tasked with doing this exercise for all the subcontracted works of a complete building. Sending out requests and collecting all the information for different elements inevitably results in a big risk of misinterpretation, omissions, and double counting. Recognizing this, at Verkerk-Evers Group, we decided to do this analysis ourselves and provide project-specific EPDs for our customized facades. By carrying out the analysis at an early stage of a project, we are able to provide the client with the right information to optimize the facade's performance. This means balancing a lot of different criteria, including aesthetics, technical performance, functionality, availability of materials, money, and of course, the carbon emissions needed to produce the facade. Take the N2 building of the Nova development in Victoria, London. Here you see the EPD for the main facade type FTO1A, which is published on Eco-Platform. As this shows, the content of an EPD is mainly a big table full of numbers. There are many different environmental categories listed: ozone layer depletion, toxicity, over-fertilization, and global warming potential. This last issue, often simply called carbon, is the key focus for most clients. In our EPDs, we usually focus on the life cycle stages A1 to A5 until practical completion of the building. As you can see here, the value for this facade type is 1,445 kilograms CO2 equivalent per facade element, which is 271 kilograms CO2 equivalent per square meter of facade. The question, of course, is whether this is a lot. One thing I would like to emphasize is that this value must not be seen as the Verkerk-Evers performance. The figures for each facade type will always depend on the individual design and supply chain of that project. This calculation is based on the default supplier processes and shows the performance that we can always deliver without specific agreements. In this way, it serves as a good baseline to start optimizations. The pie chart shows the proportional impact of different components. Glazing and aluminium extrusions are the two main contributors, followed by the opaque spandrel panel at the floor edge and all the other small materials. Transportation makes a much smaller contribution, along with energy use, processing and waste during facade assembly and installation. A certificate at the end of a project is nice recognition of the work done, but it doesn't change anything. The important thing is to use the knowledge gathered to improve the performance of facades. In recent projects, we have carried out calculations for an EPD during the early design stages and used them to optimize the facade design. The first step is a very basic reduction of all the material that is not strictly needed, because every kilogram of material will need to be produced first. The next step is a comparison of different material options. The outside of an opaque panel, for example, can be cladded with a wide variety of materials. This is not as simple as comparing a kilogram of one material to a kilogram of another. Volumic weights are different, but also their strength, specific thicknesses applied, and fixing methods. All design implications need to be taken into account. Once the materials have been chosen, we look for suppliers who have already improved their production processes and reduced the associated carbon emissions. Finally, this analysis is likely to show which materials and processes currently have a much more limited environmental impact and need less focus. We were the first company to achieve an EPD for a custom-designed, unitized facade system. Now our focus is on maximizing how the analysis that underlies a fully verified EPD can be used to improve the embodied carbon of future facades. As explained here, the key is to focus on the big impact components, including glazing, and to introduce reduction measures at the design stage. You don't need a perfect life cycle analysis to start improving your product. The sooner you act on information, the better.